Your Academic Skills Center presents this video series to help you strengthen your statistics skills.
Hello stats students, and welcome to the video presentation for confidence interval analysis. My name is Janine Allwright, and I am the instructional specialist at Walden's Academic Skills Center, where I lead the statistics tutoring team. In this video presentation, we will venture into the basic concepts of inferential statistics, and we'll talk about using the sample mean to estimate the population mean. We'll talk about two methods to estimate the population mean, and I will also explain the formula to calculate the confidence interval. Luckily for us, SPSS will do those calculations for us. We will visit Magnussen's blog, which provides an awesome interactive visualization of the trade-off between confidence levels and sample sizes. And I will share with you how best to set up your confidence interval analysis and show examples in SPSS that we'll interpret and analyze. We will also reflect upon the underutilization of confidence intervals in the literature. And lastly, I will share with you how best to save and export your work. Let's get started. If you viewed earlier videos in this video series, then you are familiar with this figure here on the screen that I've used to show how a sample can be a stand-in for a greater population, and they are connected through the process of inferential statistics. For a confidence interval analysis, we are going to estimate the mean of a variable in the greater population by using the mean of the sample. And there are two different approaches that we can use here to estimate that population mean. We can take a limited sample and use the point estimate of the sample mean. For that one sample, we'll calculate that mean of the sample, and it stands in for the population mean. The drawback is that we're only sampling once, and that it's very well possible that we will deal with an error, that there will be a distance between that sample mean and the population mean, and that's called a sampling error. A second method is to use an interval to estimate an interval in which the population mean will reside. It's a range, if you will, and it allows us to sample more than once. And as reasonable researchers, we will take into account that maybe we will make some errors there, but we can incorporate that error, and it's known in the field as a type 1 error, also called alpha. The interval is set at a certain level, the confidence level, and that comes out to a total of 100% minus that chance of making a mistake. So 100% minus that set alpha level. And in our field of social science, a confidence level of 95% is considered the golden standard. Anything lower than that might be appropriate maybe for exploratory research, but it will certainly not drive social change. A confidence level higher than that, maybe at 99% or 99.9%, is often seen in the medical field for medical trials. The interval will exist of two numbers, that point estimate minus the margin of error, that's the lower number, and the point estimate added to the margin of error. I've written them out here in bracket form. We can see the smaller number on the left and the larger number on the right. That is the approach that we will use in this presentation, and we will not work with solely one sample and one point estimate. Now let's move this forward to the confidence interval formula that we can use to calculate the confidence interval. As I mentioned, SPSS will do that for us, but it never hurts to know what is happening behind the scenes. And here is the complete formula, and I will explain the different parts here. First, X stands for the sample mean. That's the average of the sample. The Z is the confidence multiplier that is actually determined by the confidence level that you set. If you set a confidence level for 95%, you have a 5% chance of making a mistake. That's your type 1 error, and that relates directly to a Z of 1.96. The sigma here is your standard deviation of your sample. The square root of n is the square root of your sample size, and together that makes up the standard error of the mean. The total of this yellow area is called the margin of error, and that completes the formula. Now I want to explain a couple of words here and how we use them in statistics. I will share with you that different statistics books might talk differently about confidence levels versus interval and their interpretation, so I can only share with you how I was taught. When I set the confidence level at 95%, I will define that before I start the data analysis process. Oftentimes, that is actually set already before you start collecting your data, so the alpha, the type 1 error, is determined early on. That is what we consider the golden standard, and what you are expected to set as well at that level when you work on your dissertation, should you engage with a quantitative methodology. The confidence interval is that bracket between which the true population mean lives. It's that range where that population mean falls 95 out of 100 times. So that is notated with the lower number on the left inside that bracket and the bigger number on the right side. Now, I was taught that the confidence interval is not an interval within which we are 95% confident that the population mean will fall. It is merely an interval where the population falls. If I sample 100 times, it will fall there 95% out of the time. There is an awesome interactive approach available online, and some of Walden's courses in statistics actually show that as a required resource. It can be found on that website that is listed on top here, but I will make sure that I link that in the transcript that belongs to this video. And I would like to take you to that interactive visualization so we can take a look at it together and interpret that. And here is the actual website. Now, the interactive nature of this helps our understanding. And let me explain how this works. This is just a random continuous variable that is being sampled in a greater population here. I can use, for instance, hours worked as the variable here, and we're sampling the greater population and asking that question to a different sample over and over and over again. These black lines that you see appear here at the bottom of the screen are different samples. I'm sampling again and again and again and again and again. The sample mean is known, of course, it's that blue dot. And the bracket, the population mean, lies somewhere on that black line. And you can see here that this bracket is rather wide. I've set this to 95%. And I can maybe shrink that a bit if I would be willing to sacrifice an error. Right? If I would be sacrificing the chance of making a mistake is now set at 5%. We know that. It's that leftover from that 100%. If I'm willing to increase the chance of making a mistake to, let's say, 10%, and I slide this to a confidence interval a confidence level of 90%, we can see that line shrinking a little bit. I have not yet talked about that red line. The red line that you see appearing is that 10% chance of making a mistake now. And there are more red lines now than there were at 95%. I have higher odds of making a mistake. I've mentioned to you that 95% is the golden standard, so I don't really want to be here at 90%. So I'm going to put that back to 95%. And I'm stuck again with that wider line. Did you see it change there? 5% chance of making a mistake. There are my red lines. Now, what can I do to become more exact here? I want to be a little bit more exact in estimating where my population mean is going to reside, so I can change the sample size. I'm going to increase the sample size here at the bottom by clicking on that plus, and let's just keep moving up here. And while I click that, you will see that black line shrink. You see that? I'm getting a tighter confidence interval. I'm becoming more exact in finding out where that true population mean resides. And that is what this trade-off is showing you. Don't change the confidence level. Leave that at 95%. But if you want to become more exact, you can increase the sample size. Now, even sample sizes have their limitations, right? We cannot keep increasing them because it becomes a cumbersome and expensive process, but you will have to find that balance there. That is a balance that is for you to decide upon. Now let's return to the PowerPoint to see how we can set up a confidence interval analysis. And here we are. I recommend that you work exclusively with a continuous variable, as a confidence analysis of a categorical variable is not adequate. Draw a limited sample of 100. We'll run both the 90 and the 95% confidence level. We repeat that with a sample of 400, run both again, and then we will compare the width, width, of the confidence interval for our interpretation. With that, let's move to SPSS and actually run this with a couple of examples. This is the same data set that I've used before. It's the CDC data set. And I have some nice variables here to use. They are all scale. And here's a variable that I'm rather interested in. It shows us the mental health, the physical health of the participants that filled out the survey here. Let's choose the number of days that the participants did not feel good as far as mental health is concerned. The first step I want to take is I want to click on the data view here at the bottom of the screen, and I want to learn how many participants really live in this sample. Now, this is a rather big data set, so I can bring this all the way down. There are different ways to do this, but this is, a nice way to engage with how many participants there really are. So there are 2,000 participants in this data set. I'm going to remember that number. I'm going to first pull a 100 sample out of these 2,000s. And for that, I'm going to click on the Data button. And I'm going to select Cases. This is not related yet to a variable. This relates to the whole data set, and I'm going to ask for a random sample of cases. Click on the Sample button, and I would like to ask for exactly 100 of total. I put that number in here. That's the total number of cases in this sample. Now, some people will take the approach of just adding a really big number there or entering a really big number there. I find that SPSS is a bit flawed for that approach. So I work with exact numbers here, 100 out of 2000. Let's click continue and click OK. And you can now see what happened here on that data set. I can see that SPSS has crossed out most everything here except 100 that are still around, right? Now for this sample size, I can go back to variable view, click on the Analyze button, bring up descriptive statistics, and we're going to use the Explore function right on top of here. I'm going to bring my variable over, how many days participants didn't feel mentally well. Bring that over into the dependent box. Click on statistics. And I would like to start with a 90% confidence interval first. Click continue. Now I don't need any plots. I just need statistics. So I'm going to unclick the both option here and replace that with the statistics only. Click OK. And as we say, I'm going to run it. Here's my output. And this is just the summary of this confidence interval. I can see at the moment that 22 people of those 100 chose not to share how many number of days they didn't feel well mentally, but that problem will arise with every variable, so don't worry about that. It's going to be consistent. The mean for this sample, for these 78 people, is 12.73 days. That's my sample mean, and the population mean lies between the upper bound and the lower bound, between 8.59 and 16.86. That's a 90% confidence interval. Now let's run that again for a 95% confidence interval. I can just go back to that same Explorer function, leave everything the way it is, and change my confidence level to 95%. Click continue and run this. Here's my output. I can see now that I have the same 78 people, but I have a 95% confidence interval. And let's run this again for a 400 sample. I'm going back to my data button. I'm going to select 400 cases now. Click on the sample. This is a little bit of a goofy situation because I'm on a Mac. The PCs don't have that, but it looks weird here now, right? So I'm going to click cancel and do a quick reset here. Start over. If you have that same problem when you're working on a Mac, so then use your reset button. Random sample of cases. I'm going to ask for exactly 400 of that total 2000. Click continue. Click OK. Run the analysis again. Explore. My variable is still there. That's all good. I want to be consistent and start with 90%. Click continue and run it. Here's my 90% on a 400 sample. And I'm going to quickly do that again for 95%. Continue and run it. And as you can see here on the left, I now have all 4 cases, 1, 2, 3, 4, on my screen here. To summarize how we ran this, it's written here on the slide. I first checked the data view for total participants. I used data select cases and I set the sample size to 100 first. And I ran these confidence levels at 95% and 90%. And then I went back and ran it in 400. Same 2 confidence levels. And I asked for statistics only and no plots. And now that we have summarized how to run this in SPSS, it is time to interpret all this. We've calculated all the numbers in SPSS. Now let's go back and calculate the width and interpret them. So we'll first look at that on the output file. Here are our 4 scenarios. Let's bring this up and start at the top. I now know that the sample mean came out to 12.73, and my population mean lies between those two values, between the upper bound and the lower bound. When I move to the 95%, the confidence interval, my lower bound is 7.73, my upper bound 17.73. For my 400 sample, we started with a 90% confidence level, resulting in a lower bound of 10 and an upper bound of 13.06. And lastly, we ran the confidence interval for the 400 sample at a 95%, resulting in 9.7 and 13.36. I have summarized these values for you and calculated the width of these confidence intervals, and I've placed them in a nice table on the PowerPoint, and let me show you what that looks like. And here are the results. And you can see here that the sample mean for 100 came out to 12.73, and for a sample size of 400 came out a little bit lower, 11.53. And I can see the lower and the upper values for both the 90% confidence interval and the 95% confidence interval. And when we start at 90%, when I take the upper value and I subtract the lower value, I get that width. And I calculated that 4 times for all 4 scenarios of the combinations of the sample size and confidence level. And I can see here that if I sacrifice another 5% chance of making a mistake and increase that type 1 error to 10%, yes, my width will shrink. But is it really worth sacrificing that 10% if I can get in the same range when I increase my sample size? And that is the moral of this story. Don't change your confidence level, but rather work with an increased sample size, because look what happens here. If I keep my type 1 error at 5%, I can bring the width down to 3.66. One could argue that it's not as tight as a confidence interval for a 90% confidence level. But if I want to decrease that width further, I should definitely increase my sample size. Now, the last mention that I want to make here is that confidence intervals are often underutilized in the literature. Let's reflect on that and see what that means. And I think we should go back to the numbers. If we don't present our population means as intervals, but merely as sample means and have that sample mean stand in as a point estimate instead of a range for the population mean, you can see that sometimes I'm not going to be exact. Right? I have a higher chance of making a mistake if I just use one sample and if I just use one number as a stand-in. And so I want to encourage you to work with confidence intervals and not focus on just a point estimate for a sample mean as a stand-in for the greater population. We will return to SPSS to save and export our work. Let's bring up the output file that we created, and here it is. I can right-click in any white space here outside of any of the tables to use the export command. If you can't find that option with your mouse, you can also use File, and the export command lives here too. Click on Export. Make sure that you're in a Word setting. There's the Word document. Click on Browse to control what to name this file. I'm going to place this on my desktop, and this is my confidence interval analysis. Click on Save, and now I can generate that file, and I can actually go to my Word and call this up. Let's do that in Word. Now this is going to be a new file, so you will not be able to find it in recent. And here it is. I can bring this up now, and it has now created itself in Word. As I mentioned before, you can choose to write your paper in here, but I prefer a copy-paste approach. So you can take some of these unnecessary tables out. Careful though, all your output, your original output, shall be shared in your paper, preferably in an appendix after your reference list. But for that, I'm going to refer you to the APA 7 book. And with this last save and export function, our confidence interval analysis presentation has now come to an end.
Thank you for watching this video presentation. If you have course-level statistics questions, reach out to our stats tutors at statsupport@mayo.waldenu.edu or view our statistics support resources at academicskills.waldenu.edu.